Hello everyone, today we are walking through the initial phase of our user behavior analysis for the Simplicast platform. Our goal is straightforward. We want to move beyond simple counts and understanding the concept. By applying association rule mining, we aim to uncover which features are used together. Do users who upload an image immediately? Should I send them a campaign immediately? This script covers the fundamental data loading, profiling, and the critical component outlier detection to ensure our uh, predictive model is accurate. So let's start our coding. So in the beginning, you can see here we have actually loaded all of our necessary libraries. And here you can see our data loading uh, part. So for data loading, what we did, we exported the data which has been generated by the SQL query in the database into two different CSV files. One CSV file is uh, for user behavior and another thing is for each session. So here are some behavior of them. Now we have used pandas read CSV and load the data. And if you can see here, we have done some info. So in the user level data, it captures lifetime behavior of a client, and the session level data, it captures workflow of a single login event. In the code, you will see we have using performance tracking, and also when we are clicking here, the info, you can see whether our data type is correct or not. So here you can see user ID is integer and this is object. So our data set is correct and this is dead. So now let's see the data profiling. So before we run the model, we must profile. So what we did, we notice a common data quality issue, white space in the database entry. So we have tried to remove this white space by calling pandas strip method, string strip method. So in there, the milestone name, it is only the string column. So we used strip and clean the dataset. And here also we did the same thing with session. Then we have gone through the outlier analysis, the same thing we done for the clustering approach, the IQR method. By doing IQR, we try to find outlier. So here you can see we have some outlier, but we didn't uh, we didn't actually remove them because association rule mining is not a distance-based machine learning algorithm. So here a outlier can have a significance. So because it can help us to find different kinds of pattern which is associated with another thing. So that's why though there are very little amount of outlier, we did not remove it because this algorithm can work fine with outlier. So rest of the thing will be explained by my other teammate.
I'm Vijay Chaudhary. So let us get to explore our data first. At first, we have done a bar chart for record counts. Here we have got for user level and session level, we have got total number of events, unique users, and unique milestones. So we have found that there are 12 events per user and 7 events per session. So because it is needed to predict how the data set size is, the transactions are large or not, and the highlights the how diverse our data. So after that, we have run the another bar chart, which is frequency milestone frequency bar chart. So here we have found we have taken a top 15 milestones. So we have found the many steps, and in both level is in higher positions. So here we found 1700 times for user level and 30,000 is the for session level. So it is happening. So it is important because for association mining, the number of items and the frequency and directly affects the algorithm. So we have omitted those rare milestone which is create noise. So after that, we have run the logarithmic frequency plot to count the, to it will help to see the sparsity and confirm the power level distributions. So we have found here that a few milestones dominate the majority, and for instance, 10% milestones are account for 36% almost for all events at user level, and 48% session and account for in the session level 48%. So, and after that we have run basket building and one hot coding because it is a key steps to preparing the data for associated mining. So basically a basket is a collection of milestones group either by user or session. So, and we have dropped the baskets which is less than two because this is not meaningful for our association mining. Then after that we created a binary transaction matrix here, which the row represent the baskets and the column represents the milestones. So, and here after running this code, we have got the transactions matrix contains of more than 2000 baskets and 112 milestones for user level, and more than 20,000 baskets and 112 milestones for session level. So after that, we have run association mining by hyper tuning. And here we have calculated the support confidence and lift. So because it will measure the instance of relationship between these two items, so, and after that we have found that running that we have found the manage tab and report tabs appear together with a high confidence and lift, and saying strong, they have a strong recurring pattern. And for the session level, we have found that add image and update image shows extremely high lift. Here, extremely high lift and confidence. So, because they are indicating that there are very specific workflow within the session.
Myself, Soundarya. So here we'll see like how we have executed the a priori algorithm, and we could able to see like what support we have given for the user, and session like 0.40 support, which is the higher support we have given to the user, and 0.70 for the higher like confidence we have given to the user. And for a session like we have given 0.05 and 0.80 as the support and confidence. So since like it is a user level, it is having a long term interest. So in session level, like it is having the immediate workflow, that's why like we have given that. And we have got like 23 rules generated for user and 30 rules generated for the session, and some of the rules were here generated. And here we will see like what is LHS and RHS. LHS is kind of a trigger action, it's what like user do first, and RHS is a kind of the result, and it's like it's what the user do immediately after. And here now we can see the perfect example like upload image and add image. So if the computer is telling us to like upload the user's photo in a file something, so their very next thought is to put it into their project. So now we will see like how things were like correlated to each other, and we have done we have given the lift value to the heat map to check their correlation. And now we could able to see the reports tab and manage tab are like highly correlated, and send now and re-edit project are like highly correlated. Here we could able to see the session level correlation using the lift value. So here opens and bounces and open data is like highly correlated, and others have like a good correlation. Coming to the hyperparameter tuning, like we have like lowered the support value, like we have given 0.50 as a support, and confidence level as 0.80. And for the session tuning we have given 0.05 and as a support, and confidence as 0.85. And here we after like tuning we could able to see like 6 rules were generated out of 23, and 19 rules were generated for the session out of 30. And now we could able to see the correlation after tuning. And again we could able to see the manage tab and reports tab are like highly correlated, and here upload image and add image are like highly correlated. And we have exported these values to the rules to the CSV files, and user level is like values were exported to like user rules were exported to user level, and session rules were exported to session level CSV files. And here we could able to see some of the values, top workflows, top user level values. um, we could able to see it here. So coming to the CSV file, here like we could able to see the values, and support is nothing but the popularity. So in the user level, like going to the manage tab and reports tab, the support is like 0.57. This means like 57% of all users follow this pattern, and the confidence is like we will call it as a certainty, considering like upload image and add image in the use session level. Like it has confidence of 0.097, which is means like a 97% guarantee. If they do this first thing, then like we are almost like 100% sure like they will do the second. And lift is nothing but a correlation. And here like we could able to see 8.10 for like opens and bounces, and open data having like a higher amount of lift. So the left, which is one, means it is not like a good having a very good correlation or relationship, any relationship. So when it is above 1, it is a good relationship, and when it is like having a 8, it means like two things are like magnets. They are like incredibly powerful partners that almost never happen without each other.